In the next series of videos, we're going to begin talking about Tanzu application platform. Now, TAP is essentially the next generation of Pivotal Application Service, which was based on Cloud Foundry and has now been branded to VMware Tanzu Application Service. Okay, TAS was built on the Diego container runtime just before or around the time that Kubernetes was released. And TAS was very successful and continues to be today. But organizations, they hear the buzz about Kubernetes today, and they can be a bit skittish, I'm afraid, of buying into something that does not run on top of Kubernetes. Hence the birth of Tanzu Application Platform. Okay, so TAP is an end-to-end automated supply chain that helps us minimize the amount of time an application can be made available to its users from the moment the code is ready. Now, I am not making any sales pitch here by any stretch. I just want a high-level summary for us of what it does and what challenges it attempts to solve for organizations looking to bring a DevOps methodology to the forefront. And this will help us, obviously, since we're going to be installing and running TAP. From our perspective, this high-level overview will help in that regard. And of course, this is too big of a subject for anyone, including myself, to cover in just a couple of videos. Now, just a disclaimer here, if you have not set up the Tanzu CLI and Cluster Essentials, you will need to refer to both the operator prerequisites and the Tanzu prerequisites videos that were made previously, or for that matter, you can refer to the script files in our downloaded ARIA operations repository. The first one that will need to be run is this operator prerequisites file. Okay, and this is going to install the very essentials here, right? So we're talking about Docker. We're talking about these tools that deal with JSON files and YAML files and the AWS CLI and Azure CLI and so on and so forth, kubectl. Then you'll want to install the file in the operator/AWS folder called Tanzu prerequisites. Okay, so this will be all of the Tanzu specific packages. I have not tested this on a Mac. I have not tested this on other distributions of Linux, or I've not even tested this on my local Windows desktop. I went straight to the Ubuntu on AWS, and that will be my jump box. So if you are using any of those others, you will probably need, or you will most definitely need to manually modify these scripts for that environment. Okay, so let's think a moment about the common steps and procedures necessary to get an application to production. I'm going to try to make this a lightning round here. I don't want to spend too much time on this, but I think it kind of brings us to the introduction of TAP and the challenges that it attempts to solve. So those that are familiar with agile methodologies and software iterative development will recognize this diagram, right? So it all begins in the middle where we have our planning phase and all the teams come together to decide, given their respective roles, what will be necessary to bring this application to fruition. Then the developers start writing the code. They've chosen a language stack, and then the build stage makes sure that that code measures up, right? It passes compilation and that there's no syntax errors and so forth, so that we can bring artifacts from this phase into the testing phase. And this is where we would make sure that we want to run things like unit tests and integration tests. Tests fail, right? It's going to go right back to the coders. And so the coders have to make sure that all the tests pass in order for the process to proceed. Now, this whole left side of the diagram is the continuous integration phase in our CI/CD acronym. Okay, so the release stage is where we are going to generate the outputs for the target environment to be deployed to. Maybe it's public cloud, maybe it's on-premise web server or container orchestration platforms. And so that's what the deploy phase will determine. That it'll take the release bits of this and deploy it to the target environment. Then we get to the operate stage. Okay, so this is where Operators in particular will make sure that the hosts the application is running on is properly configured, that operating systems have been patched and updated, and so on. And then we get to the monitor phase, where we're going to be on the lookout for issues. So we'll be keeping track of things like health metrics and performance. We'll be checking logs, on the lookout for alerts about any potential issues, so that we can address those proactively before they become any kind of problem. And so the right-hand part of this diagram is going to be, sometimes it's continuous delivery, sometimes it's continuous deployment, but it is our CD part of the CI/CD acronym. So everything that we learned here, we get feedback from what we've been monitoring, and we bring that to the next planning meeting for our next release. And so the cycle just goes on in ad infinitum here, and that's why we have this depicted as an infinity symbol, because this just goes on until the application is either retired or replaced. But let's put some of this into meaningful, concrete terms. Here we have some of the tools that are implemented in each of these phases. So insofar as our code is concerned, most likely going to be hosted in a Git repository. Then we get to the build phase, where in this case, we've got Maven. Maybe it's Gradle for Java apps, or MS Build for .NET apps. Then we get to the testing phase, where things like JUnit or NUnit release. Okay, most of us are probably familiar with Jenkins, and its job is to give us artifacts that are ready to be used and deployed to the target environment. Okay, maybe it's a container image from the release phase. Maybe it's an executable for a Windows server, or maybe it's to be hosted on some kind of platform as a service on AWS. And then we get to the operate stage here, right, where we're using tools to make sure that our hosts and operating systems are properly configured. Maybe we're using a container orchestration tool such as Kubernetes. And then we have our monitoring tools down here for capturing logs, metrics, performance issues, and those types of things, APMs. But we have to take a step back for a moment and ask ourselves the question, how are we going to stitch all of these disparate tools and services together so that they work as a single unit and give us a complete automated end-to-end pipeline? Well, that's where TAP comes in. And what I want to do now is map these phases of our CI/CD diagram here to components that run inside of TAP. So here we are on the docs page for Tanzu Application Platform, and this is our reference architecture document. Now, we should recognize these vertical stacks here because we built these as EKS clusters in a previous video. We've got TAP View, we've got TAP Build, and we've got TAP Run. Now, the only cluster that I'm not going to be concerned with in this series is the iterate cluster. And this is a sandbox cluster environment in which we can create for developers so that they can test and debug their code in a live Kubernetes environment. And so the idea is that as a developer, I can connect or attach my IDE, such as Visual Studio Code, with all of my source code files and so forth, with breakpoints hit. I can attach it to my application code running inside of a pod of this iterate cluster. And the code will actually stop on those breakpoints that I've defined. And then I have the ability to use my usual IDE tools to step through, trace through, and see the behavior of my application as it functions and runs within inside of a pod. So let's go ahead then and start with the components in the build cluster. So the components that deal with the source code and the Git repository are the Flux source controller here. And the Flux source controller is always going to be continually polling my Git repository for code commits. And if it detects any code commits, it's going to pull that code down so that it can run the code scanner. Now, the code scanner is going to be responsible for running static code analysis to detect any common vulnerabilities and or exceptions, our CVEs. Now, out of the box, the code scanner that's supported by default is going to be a gripe scanner. And we also have support, if not now, it's on the roadmap for Sneak, Carbon Black, and I believe that there are others as well there. Okay, so once Code Scanner approves the code, it has detected no critical or high vulnerabilities, what have you, whatever you've defined in your policies. It's going to pass the code off to build service. Now, build service is actually a separate standalone product by VMware called Tanzu Build Service. Tanzu Build Service works in conjunction with cloud native build packs. And these work by determining or inspecting our code to determine the language stack and then choose the appropriate build tool. So it'll look, and if it sees a certain file with a certain file name extension, so for example, a POM XML file, it knows that it needs to use a Maven build tool. Then once it does that, it builds our code. It's going to run unit tests on the code. Now, I can't remember if it builds the image first or it runs the unit tests. So it's going to run a Tecton pipeline. Tecton pipelines are built with YAML configuration files, and they're made up of tasks. And each task is configured to run a unit test. So that's where Tecton comes in. All of these are open source products. And so once the unit tests pass, build service will then go ahead and create our OCI compliant container image and push that out to our container image registry of choice. Now think of that for a minute. With no Docker files here, I don't have to manage and write and maintain Docker files. Build service is going to do that all automatically for us and give us a container image. So let's go ahead and move on to the run cluster. Now, not only does the Flux source controller monitor our source code repository, but it can detect changes and uploads to our container registry. So this arrow actually here should be bidirectional. Okay, so we've got the Flux source controller here. Then we've got the cloud native runtime that operates on top of Knative. And then we're going to talk about the services toolkit in a subsequent video when we bind or attach dependent services to our application, such as a database, and get connection details through these bindings here without having to embed the credentials within our source code. And then finally, our view cluster here on the right is actually based on the open source software made by Spotify, which is called Backstage. And it's a developer portal, okay, and provides some observability into the performance of our apps with a product called App Live View, which is not depicted here on the diagram. It's also a portal for detecting and discovering and testing APIs that were published by other teams in our organization. You know, there's so much more offered by TAP, but I've only chosen to discuss those components as they map specifically to the phases in our CI/CD infinity diagram over here. So if we can just sum up, we've got the code phase where we have Flux source controller continually monitoring our Git repository, pulls any code commits down, builds that source code after it runs scans, image scans, and static analysis scans, and then can run a Tecton pipeline, which can execute all of our unit tests. And so when we get to the release phase, this is where, so all of this was accomplished by tap build. And then when we get to release, tap build or build service outputs that OCI compliant container image, which is stored in our image registry. And this is where we move then to our tap run cluster for the deployment phase, okay, which hosts our application on Knative. And so since we're using Kubernetes, our operations will be taking care of things such as, you know, auto scaling, self-healing of our applications. Kubernetes takes care of all of that. And then we get to the monitor phase where we're talking about tap view, being able to monitor the performance and health of our application. Does not support logs yet. That would probably require another component for us to view those types of things, application traces and so forth. And actually, we're going to talk about that when we talk about Tanzu observability. All right, so in the next video, we are then going to install our prerequisites so that we can install the components over here in our 3 tap clusters. and our fourth tap cluster on AKS. Okay, thanks for watching, and we'll look forward to seeing you in the next video.